Okay, class. Bismillahirrahmanirrahim. Assalamualaikum and very good evening to all of you. Welcome to the first class of BAA 2213, the Reinforced Concrete Design 1. Okay, first of all, I would like to ask to all of you, have you finished my video? Finish?
Yes,
watch?
sir.
Okay, thank you so much. Okay, one question from me. Okay, why do you think we need reinforced steel reinforcement inside the concrete? Why we need?
So that the concrete won't be easily cracked.
Okay, won't be easily cracked. Okay, good answer. Any answer? Any other answer?
Doctor, may I?
Okay. Vignesh, okay.
Okay, so the reason why we need reinforcement in concrete is because when forces act on concrete on its own is brittle because it only has aggregate, sand, cement, and water.
Okay.
So we need this reinforcement so that the tension forces and the compression forces that act on concrete do not cause it to crumble immediately, allow it to sustain the load for longer periods of time.
Okay, good. Okay, so I believe you already gone through these notes. Okay, this is the properties. Okay, the properties between the concrete and the steel that enable us to combine both materials together as a composite. So we call it as reinforced concrete. Okay, because the concrete is poor in tensions and the steel is good in tensions. So the tensions, which is caused by bending moment, will be catered by steel, while the compression will be catered by the concrete. Okay. Okay. One more question is okay. I believe you know already. Okay. Can you see my screen?
Yes, doctor.
Yes, sir.
Okay. Okay. Good. Okay. Thank you. Okay. Okay. Sorry. Do you prefer this? Do you prefer like this one? I don't think so. It's okay. Everybody know me. Okay. What is more important is the clear voice. Okay. Okay. So this is a simply supported. Simply supported beam means that a single span beam which is supported at both ends. Okay. So by the action of load, yeah, I mean the vertical load. Okay, along the beam, it will cause the beam bend like this one. Okay, so the tension, okay, here, the cross section. So the tension will be experienced by which part, bottom or top?
On top.
Tension. I asked the compression or tension? Compression, right? Okay. Compression, okay, will be experienced by top region here. This is will be the compression, and the top part will experience the tension here. Okay, it will experience the tensions. So that's why the crack will occur. Is expected to occur here because the concrete is weak in tensions. So that's why we have to provide the steel here as reinforcement at the bottom part, and at the top part we provide as hanger bar, or if required, okay, as the as prime as required. Okay, if the concrete here cannot cater for very high compressions, so we will put as this one as prime. Okay, I believe you know about this one. Okay, that's why here we put the steel reinforcement here. Okay, okay, this one the plane. Okay, this is the shape of the bar, the type of the bar. Okay, may I know this the yield strength of this rounded bar? Or we did not SR usually in our drawing. What is the yield strength? Or the FYK? Okay, what is the yield strength of the bar? Anybody know?
250.
250. Okay, good. Okay, the unit. This is very important, class. This is very important. because the information will be given by text, which will usually confuse you. Okay, 250 the units. How about the units?
Newton millimeter square.
Newton. Okay, good. Newton per millimeter square or megapascal. Okay, Newton per millimeter square is equal to megapascal. Okay, how about this one? Okay, the deformed bar. This type of bar. What is the value of Fyk? Anybody know?
500.
500. Okay, good. 500 usually used in practice, or unit is Newton per millimeter square. Okay, it depends on country. Okay, sometimes some region the country provide 400 to 600. Okay, but here in Malaysia, the producer in Malaysia already can produce this level of strength. Okay, good. Okay, another properties I want to ask is about this one. Okay, concrete characteristic strength. Okay, this one. Okay, this is the meaning. Okay, what is the characteristic strength of this one? Okay, C25. C20 means 25. What does it mean? 20/25. What is the meaning?
Cube and cylinder.
Okay, cube and cylinder strength. Okay, cube and cylinder strength. Test by cube or test by cylinder. Okay, which one is cube and which one is cylinder? Which one is cube?
20 cylinder and 25 is cube.
Okay, good. This is cylinder. Okay, cylinder sample, and this one is cube. Okay, maybe next year you are going to the lab. Anybody who doing the concrete material research for your final year project. Okay, you will ask your supervisor either to use cylinder or cube sample. Okay, so the cylinder sample we did not as FCK, and this cube sample is FCU. So the FCU here is 16 and this one is 20. How about this one?
25.
Okay, 25 here. Okay, good. 30 and then next.
35.
35. Okay, this one. 30.
37.
Okay, it means that if you do the mix, okay, after if you mix a concrete, okay, it depends. Okay, if you want to use the cylinder cube, okay, let's say this one, okay, the cylinder cube. Okay, you find this one. Okay, maybe I'm not sure. Sorry, this is 100 mm the diameter, and this is 150 mm. This is the cylinder sample. So at 28 days, it must achieve. If the concrete class is class 30/37, means that your mixture must achieve the compressive strength of 30 more than 30 Newton per millimeter square at 28 days. Okay, more than or equal to lah at least. Okay, but if you use the same mixture, but you use the cube. Okay, let's say you use the cube, you don't have a cylinder mold, you use the cube. Okay, 150 times 150 times 150. Okay, how much the strength it must achieve after 28 days? Compressive strength. Okay, this one is FCK. Okay, the value of FCU shall be what?
37.
Okay, good. 37 Newton per millimeter square. Okay, so you must not confuse. Okay, because we will use a lot of concrete strength. Okay, this one is the hot roll code work. Okay. Okay, I believe you know. Okay, one more question is about the beam. The beam. Okay, sorry, not here anymore. Okay, Okay, and this is beam, this is questions. Okay, this one. Okay, for these notes. Okay, this is the strength. Okay, this is the FCU. So the FCTM. This is you will use this value to determine the AS mean later. Okay, the AS mean you use this value FCTM. Okay, in the equation to determine the AS mean you use this value. Okay, so please be careful to select from this table. Okay, and okay, this is the simply supported beam, and this one is for okay. This one is for the continuous beam. Okay. Okay, let's you see here. Okay, this is the midspan. Okay. Okay, let's say we have three types of a beam, a continuous beam with three spans. Okay, this is quite confusing. Okay, if you please you don't have to memorize the step of work. You have to understand. You just have to understand the how it works. Okay, the concept. If you memorizing the step of works for your final exam or for your for your for your test, I'm afraid that you will make a mistake. Okay, I'm so sorry to say that I'm here not to train you how to score in your exam, but I'm here to train you how to become a competent engineers in the future. Okay, about the final exam, you can think yourself after you understand the concept. Okay, so let's say we have a three uh, beam with three support here. Okay, support A. Let's say this is support B, support C, and support D. Okay, so this is a continuous beam. Okay, and after exposed to the vertical load, okay, the crack will occur to the okay. Let's say here is the you must clear. Okay, you must clear. Okay, you can stop me if you are not understand. You can stop me and you can ask. Even in Malay, it's okay. You can ask in Malay. Okay, I will try to explain. Okay, so this is the mid span. Okay, I use the short form mid span. Okay, the middle of the span. Okay, you can observe that the crack will occur at the middle part. Okay, at the middle part of the beam. So that's why we provide the steel here. Okay, the steel here. This is your AS. Okay, this is your AS. Area of steel provided. This is your AS. Okay, because the tensions occurred at the middle part of the beam. Okay, clear. So your okay your okay, let's say here this is your okay, let's say we use I will touch about rectangular I mean T shape or L shape beam later. Today I will only focus to the rectangular section. So the AS will be here at the bottom part here. If the compression here is too high, where the concrete cannot cater for it, so we have to provide for the AS prime. Okay, provide for the AS prime. If the concrete itself can cater for the compressions, the AS here we call it as hanger bar. Hanger bar. So we can complete our complete our loop of shear reinforcement later. Okay, so without hanger bar, we cannot construct the shear reinforcement. So we need the hanger bar. Okay, clear? Any questions up to now? If okay, so that's why you must be able to read. You must be able to understand. This is what happened in our last mid-sem. Okay, the questions ask you to do the okay. So if okay to analyze the section at support. Okay, at support. This is at the mid-span. So the mid-span. So the The stress block is like this. Okay, this is for compression and this is for tensions. Betul tak? Okay. Compression is at the top and compression at the bottom. However, if you are requested to design the sections near the support, the situation is differ. Okay, for here near the support, the crack will occur, is tend to occur at the bottom part. Okay, because the tension is at top, tension is here, and the compression is at the bottom. So if the question, okay, if you as an engineer, okay, if you face the question, so the problem, if you want to design the sections at the near the support, so where is our AS prime now? Where is our tension bar now? At the top or at the bottom?
Bottom.
Top.
Bottom. Okay. Okay. Good answer. It's okay. Good. Thank you. Thank you for answering. Okay. I really appreciate it. So we provide at the top now. Here, like this one. Okay. Here we provide at the top. Okay. So the top here. This is our AS now. Our AS now is here. And then our AS prime will be here. This is the AS prime if needed. Okay. Is if needed. So our stress block will be inverted. Okay. So this is your questions during the past. Okay, so this is your, let's say this one. This is your potential. And this one is for your compressions. It's inverted because the tension is, now tension is at the top and compression is at the bottom. Okay, this, you just, you don't have to remember the step of works. You just have to remember this concept. Understand and remember, this is at the mid-span situation, and this is at support. Okay, very simple. Okay, very simple. Okay. Okay, any questions? Can you understand? Understood? Boleh ya, siapa nak sebut nama ni? Ada pun senarai nama. Nurul Atika Abdul Rahim. Boleh? Boleh faham?
Boleh, boleh.
Sorry lah ya. Okay, sorry lah. Okay, saya pun bersedih juga dengan ketiadaan kawan kita ni. It's okay, kita doa banyak-banyak. Semoga dia tenang di sana. It's okay, jasad dia tak ada dengan kita, tapi kita anggapkan semangat dia sentiasa ada. Sebab saya terima based on the Google Form, banyak juga komen-komen positif. Dia ni orang yang baik, macam-macam lah, suka tolong orang. So, okay. This one, okay. So this one, okay. How about if you have cantilever? Do you know what is cantilever part? Okay, this is continuous beam. And simply supported beam, this one, okay, only one span. This is span, we call it a span. Okay, this one to this one, support to support, we call it a span. So this is only one single span, okay, single span beam. Okay, how about this one? How many span we have for this beam?
3.
3 span, good. Okay, this is here to here is one span. B to C is another span. Okay, so span number 2 and span number 3 is from C to D. Okay. Okay, how about the cantilever part? Okay, let's say this is you have a building. Okay, which part you usually you will find the cantilever beam? Can somebody tell me? Corridor, okay, corridor or balcony, okay. This is the one, this is ground beam. Let's say this is second floor, and this is your roof, okay. You have a corridor here, okay, corridor here. Okay, and then you have the brick wall. This here is your brick wall, we call it parapet wall. So if we take out this beam, okay, let's say this is A, this is B, and this is C. Okay, So your beam should be like this one. This is your beam now. Okay, this is your beam. The support is here. This is support A. This is support B, and this is support C. Okay, so this part we call it as cantilever. Okay, so how about the cantilever? For the cantilever part, we design the reinforcement. Okay, I mean the tension reinforcement is at the top or at the bottom. Anybody can answer? Sorry. Okay, if you have a cantilever part, okay, like this one, cantilever part, you can see. Okay, let's say after D, you have this one. Okay, a small part here. The bending moment will be like this one. Okay, this one like this. Okay, the bending moment. Okay, let's say this is the bending moment. Okay, at the bottom, at the midspan here, and then go to the top, and go to the bottom again, and go to the top, and 0 at the end of E. Let's say this is E, so at the E is the moment is 0. So the tension is at the top or at the bottom.
Bottom.
Okay, let's say this one along the cantilever part. You focus along here only, from here to here. Along the cantilever part, the stress, I mean the tension is at the top or at the bottom. You just have to refer the shape of bending moment. Okay, if the bending moment here, the bending moment go to the bottom of the beam, means the tension is at the bottom. The bending moment is at the top of the beam. Here the diagram means the tension is at the top. Then it will go to the bottom again, means the tension is at the bottom. So it go to the top again, and then along the cantilever part, usually the bending moment is at the top. So the tension is at the top or at the bottom.
Top.
At the top, right? Okay, so there's this one. Okay, you
Top.
yeah, so this one. Okay, so the tension is at the top. So the tension is here, and the compression is here. This is the compression zone. So we provide the AS is at top or at the bottom.
Top.
The top. Okay, so this one, this is AS. And this maybe become AS prime or the hanger. Okay. Okay, any question up to now?
No, okay.
No, okay, good. So you must just have to understand and remember. So okay, like this one. Okay, so this is the AS will be here. Okay, the top. Okay, so you have to remember. Okay, at the mid span. Okay, at the okay, like this one. Okay, at the mid span. This is the location of ni. Sorry, saya buat besar sikit lah. Okay, this one. Okay, macam ni. Saya buat macam ni. Okay. So, soalannya ialah, this is location. Sorry, this is position. Position. First, we have midspan. And then, we have support. Sorry, support. And cantilever part. Okay, cantilever part, this one is this one. Cantilever part, sepanjang-panjang cantilever part tu. Okay. Okay. So okay, this is tension. Tension is at top. Okay. Tension, and then this is the AS. Okay. So at midspan, where is position of tension? Top or bottom?
Bottom.
Okay, good. At the bottom. So the AS at the top or at the bottom? At the bottom. Okay, good. So okay, nanti you guna kertas lain and this is the, let's say, the stress block, like this one. Okay, maybe you better use other paper. Okay. Okay, this one, the stress block is like this one. Okay, the shape of the stress block is besarkan sikit lah. Okay. Okay, so the stress block is like this one. Okay, kalau tak faham nanti kita tanya. Maybe next week we learn how to derive this one. Okay, this is the stress block. Okay. However, at the what to say at the at the support. Okay, sorry, at the support and at the cantilever, the situation is different. So where is the position of tension? The region of tension is at top at bottom.
Top.
Yes, good, at the top. And then so the AS is at the top or at the bottom?
Top also.
Also top. Okay, so you must remember this concept. This is very, very important concept. So if you are requested to settle the reinforcement at midspan, so it must be at bottom. If you are required to settle the reinforcement at support or for cantilever beam, the reinforcement is located at the top. So the stress block will be like this one. Okay, this is for steel. Is inverted, okay, because the compression is at bottom and tension is at the top. Okay, are you clear about this one? Clear?
Yes, doctor.
Okay, good. Okay. Okay, can we have a 5 minutes break before we start with our exercise?
Alright, doctor.
Okay, thank you.